All right, let's get right into it. Today, we're tackling a skill that is absolutely essential for any Linux pro, especially if you've got your eye on that LPIC-1 exam. We're talking about how to master Linux when it's living inside a virtual machine. So let me ask you something. Have you ever gone and spun up a server on AWS, Azure, or maybe Google Cloud? Clicked a few buttons and had a new Linux machine running in minutes? Well, if you said yes, then guess what? You've already been doing exactly what we're talking about today. You've been using Linux as a guest inside a massive virtual world. So here's our game plan. We're going to start with the big question: VMs or containers? Then we'll see how Linux fits into the cloud. After that, things get interesting with something I call the cloned identity crisis. And don't worry, we'll cover the checklist and the exact commands you need to fix it. Okay, first things first, we have to get clear on the two main ways people do virtualization these days. You've got to know the difference between a virtual machine and a container. It's fundamental. So, what in the world is a virtual machine, or VM? Just think of it as a whole computer, but made entirely of software. You have this manager, called a hypervisor, that carves up the real hardware and pretends to be a CPU, pretends to be RAM, pretends to be a hard drive. This lets you run a completely separate operating system on top. And the most important part? Each VM has its very own independent kernel. Now, contrast that with a container. Containers are a totally different beast. They're super lightweight. Instead of pretending to be a whole computer, a container just wraps up one application and everything it needs to run. And here's the magic trick. It shares the kernel of the computer it's running on. That sharing is what changes everything. And this is where you really see the trade-offs. With a VM on the left, you get that full OS virtualization. That means awesome isolation. It's perfect if you need to run, say, a Windows machine on a Linux server, or if security is your absolute top priority. The catch? They're kind of slow to get going. Now look at containers on the right. Because they share the kernel, they are incredibly light, efficient, and they start up in a flash. That's why they're the darling of the DevOps world for getting apps out the door fast. This picture makes it super clear. See how those containers are all sitting on top of one single host OS? They're sharing it. There's no extra operating system layer for each application like you have with VMs. That slim architecture is exactly where their speed and efficiency comes from. Okay, let's pivot and see how this all works in the place you'll see it most often, the cloud. When we talk about Linux in the cloud, we're almost always talking about an infrastructure as a service setup, or IaaS for short. So with IaaS, a cloud provider basically says, hey, we've got these giant data centers full of servers, storage, and networking gear. We'll manage all that physical stuff, including the hypervisors. You just log in over the internet and build whatever virtual machines you need. And what are the building blocks they give you? It really comes down to three things. You've got your computing instance, that's your VM with its virtual CPU and RAM. You have block storage, that's your virtual hard drive. And you have networking, your virtual network card, an IP address, and the firewall rules that control who can talk to it. It really helps to picture this like a stack. At the very bottom, you've got the real physical server sitting in a rack somewhere. On top of that metal is the hypervisor, the software that's juggling all the resources. And then, finally, sitting right on top of the hypervisor is your guest VM, your little Linux instance that has no idea it's not running on real hardware. All right, now we get to the most important part of this whole explainer, especially if you're studying for your certification. This is what I call the cloned identity crisis, and it's all about the hidden dangers of making a perfect copy. And let's be real, cloning is fantastic. Taking a perfectly set up golden image and just stamping out copies, it's a game changer. It saves an incredible amount of time and is how modern infrastructure gets built. But what happens when your copy is too perfect? What happens when you have 2 machines or 10 machines that believe they are the exact same computer, all trying to talk on the same network at the same time? Well, this is what happens. You get absolute chaos. The network gets confused, and you get this giant, scary SSH warning. This isn't just a suggestion, it's a red alert. It's screaming at you that the server you're trying to connect to has a different identity than the last time you talked to it, and that could mean you're being attacked. So how do we stop this from happening? Simple. You follow a checklist. It's not optional. These are the 5 critical things you absolutely must change every single time you clone a Linux virtual machine. Burn this list into your brain. First, the host name, obviously. 2 things can't have the same name.
Second, the network stuff, like its MAC address and IP address. Third, the machine ID, which is like a digital fingerprint for the system's core services. Fourth, the SSH host keys, which is what causes that scary security warning. And finally, any other unique IDs or UUIDs that might be hiding in your system. Knowing the list is one thing, but you've got to know how to fix it. So let's get our hands dirty and look at the actual commands you'll use to give your clone a brand new identity.
First up, the host name. On pretty much any modern Linux system, this is a piece of cake. The command is hostname control set hostname, and then you just type in whatever you want the new name to be. Easy peasy, it's the first step to making your clone unique. Now the machine ID. This one is so important. If two machines have the same ID, internal system messages get sent to the wrong place, and you end up with all sorts of bizarre, hard-to-diagnose problems. The fix is this three-step dance. You delete the old ID files, and then you run dbus uid gen ensure to create a new, truly unique one. And what about that big, scary SSH warning? Well, once you fix the SSH keys on the new server, you have to tell your own computer to forget the old one. The error message actually tells you how to do it. You just run ssh-keygen-r and give it the server's IP address. That wipes the slate clean, so next time you connect, everything will be good to go.
Okay, let's wrap this up with the key takeaways. Remember, VMs give you isolation, containers give you speed, the cloud gives you the building blocks, compute, storage, and networking for your VMs. Cloning is awesome, but it creates a serious identity crisis. And the most important rule of all, you always change the hostname, machine ID, and SSH keys after you clone. No exceptions.
So we've walked through how to fix one clone by hand, but that raises a pretty big question, right? How do the big cloud providers do this automatically for thousands of new machines every hour? Well, the secret sauce is a tool called Cloud-Init, which runs right after a machine is born to give it a unique personality, but that's a whole other deep dive for another day.